Hi students, this is Sivakumar, 11th Standard Mathematics, Chapter number 1, Continuation of Exercise 1.2. Problem number 6. Prove that the relation friendship is not an equivalence relation on the set of all people in Chennai. So what's the statement? Friendship. Okay. Okay, I consider yes, the set of all people in Chennai. Let the relation or be defined. A is related to B if A is a friend of B, because what is given in the question? Friendship. So I consider A is a friend of B. We have to prove OR is not an equivalence relation. Okay, we start with the reflexive statement. Consider only one person. A is not a friend of A only. Correct? A person cannot be a friend of the same person. Therefore, A is not related to A, because what is the relation? What is the statement given? A is a friend of B, but what is here? A is not a friend of A. You can say, I am a friend of myself, but not always. So you have to mention A is not a friend of A. Therefore, A is related to A means A, that is, or is not reflexive. First one over. Now we can go for symmetric. Symmetric are two different cases. Okay. Case number 1, I consider A is related to B. That means A is a friend of B. Reverse, B is a friend of A. I consider B is a friend of A. But not always. In this case, I consider if A is a friend of B, B is a friend of A, I consider. Right? Since B is a friend of A, you can write B is related to A. Therefore, OR is symmetric in this case, which implies OR is symmetric. Now, case number 2, I consider A is related to B. A is related to B statement. A is a friend of B. Even if A is a friend of B, sometimes B may not be the friend of A. Correct? That is also true sometimes. So, B is not a friend of A. It is also possible. If A is a friend of B, B is not a friend of A, it is also possible. Therefore, since not a friend means you have to mention B is not related to A, because the given statement is a friend of, it is against the statement. Not a friend means you have to mention B is not related to A. Now, OR is not symmetric. Already I told you, in any one of the cases, it is possible to prove OR is not symmetric. The final result is not symmetric only. So, how to write the result from case 1 and case 2? From case 1 and case 2, it is proved that OR is not symmetric. Now we can go for transitive. Transitive, two different cases. First I start with A related to B and B related to C. Already I told you, for transitive you have to take two pairs. In the two pairs, one element should be common. Here I have taken B as common. For this statement, A is a friend of B. According to the given statement, A is a friend of B and B is a friend of C. A is a friend of B, B is a friend of C. Here B common, so I take A is a friend of C. Even sometimes A is not a friend of C. In this case, we are considering A is a friend of C. A is a friend of C. Since A is a friend of C, you can write A is related to C. Therefore, what about that result? Or is transitive. In this case, or is transitive. Therefore, or is transitive. Case number 2. I consider A is related to B and B is related to C. That means A is a friend of B and B is a friend of C. Even if A is a friend of B and B is a friend of C, A may not be the friend of C sometimes. That is also possible. A is not a friend of C. Not a friend means what I have tried. A is not related to C. If not related means what I have tried. Or is not transitive. Therefore, final result from case 1 and case 2, we have proved that or is not transitive. As I told you, if in any one of the cases it is possible to prove not symmetric, means the final result is not symmetric only. Sorry, not transitive means the final result is not transitive only. Not transitive. Therefore, generally any one of the relation is not satisfied, that is either reflexive or even symmetric or transitive, anyone is failed. In that case, the final result is not an equivalence relation. Here we have proved not reflexive, not symmetric and not transitive also. The final result is or is not an equivalence relation. So problem number 6 is completed. I'll be teaching the problem number 7 in the next video. Thank you, children.